Hi, this is Jan from Terra3D. In this video, I'm going to show you how to use the fully automated classification module from the Terra3D Rail software suite. Let's start. In the install directory, I open the folder called bin. This is where the main executable file is located for those that want to run it through the command line interface. But in this video, I am going to concentrate on the graphical user interface mode. So I launch GUI.x, which is located in the GUI directory. I will classify two LAS files that are in the following folder on my desktop. This is why I select the full directory as input. I could also have selected individual LAS or LAS files as input with the field on the right-hand side of the window. The clouds can come from any source: terrestrial laser scanning, mobile mapping system, UAV, drone. As output directory, I select the same folder on my desktop. Then I will provide a configuration file to select the classes I want to extract and the associated extraction sensitivities. Please note that this is not mandatory. If no file is provided, all the classes will be extracted with standard parameters. The config file should look like this: a list of the classes I want, followed by the selected extraction sensitivity among three levels: standard, sensitive, if I want to avoid the false negatives, or safe, if I prefer to avoid false positives. I can open this file or tune the parameters directly through the graphical user interface by clicking on View, Alter File. For example, I set the extraction sensitivity for class catenary wire to safe. I save the file to confirm my change. Then I will provide a configuration file to define the output labels. This is not mandatory either. If no file is provided, the output labels will follow ASPRS standards. The config file should look like this: the list of classes, followed by a label between 0 and 31. Again, I can open the file or tune the parameters directly through the graphical user interface by clicking on View, Alter File. For example, I set the label for class traffic light to 12. And I save the file to confirm this change. On the bottom of the window, there are a few more parameters I can set. First, if my data comes from terrestrial laser scanning and is very dense, I can help the software by signaling it. This is not the case for my two clouds as they come from a mobile mapping system, so I let this switch off. Then I can activate a fail-safe mode. It would produce faster results by skipping some parts of the process, but it sometimes leads to imperfect classification results. As I want to concentrate on getting the best results possible, I let this switch off. Finally, I can allocate more than one thread to the program in order to speed up the parts that can run in parallel. In my case, I want to allocate a maximum of 8 threads. When everything is set up, I simply click on Launch Process. The program opens a console and sequentially performs the classification for all the input point clouds. You can see the progress in the console. When the process is over, the program exports the classified point clouds into the selected output directory. Classified clouds are exported with the same name, format and header as the input point clouds. To visualize the results, I will open a classified cloud with an open-source software called Cloud Compare. Each artificial color depicts a class. For example, I can filter labels from 1 to 6 and visualize only the ground, the rails and the catenaries. And that's it. The classified point cloud can now be used for various asset management tasks such as clash detection or vegetation monitoring. This is Jan from Terra3D. Thanks for watching. Don't hesitate to contact us to get you trial license.